Hello, my name is Mr. Fontenot. Welcome to my YouTube page, Mr. Fontenot 1111. Please like, share, and subscribe. In this video, I'll be calculating the values for a purely capacitive series circuit from the Chapter 17 math handout, problem number 5. I'll be taking my known values from the Chapter 17 math handout, shown here. And you can see the values for problem number 5 highlighted in yellow. One thing I want to point out to you is that in number 5 here, we're given our capacitance values. And when we're given our capacitance values, we have to find our capacitive reactance values. In number 1, we were given our capacitive reactance values and we had to find our capacitive values. And that's something that you'll see also for number 9 through 12, you're given capacitive reactance, and then number 13 through 15, you're given capacitance. So when we're given capacitive reactance, we have to find capacitance. When we're given capacitance, we have to find capacitive reactance. I will be using the formula sheet, Chapter 17 formula handout, which you can use on the test. And I have went ahead and clipped and copied and pasted to our screen formulas 1 through 4 and formula number 9. Since we are given our capacitance values, we'll use formula number 9 to find our capacitive reactance values. So I have the steps listed here that will be taken to calculate the values for this circuit. I do want to point out to you also that for the test, you're going to have to memorize these values here in order to lay your spreadsheet out to get started. So it's VCT, VC123, you see the I's, you see the X's, you see the T's. I will not provide that spreadsheet for you. You will have to write it out from memory and then do your calculations. So the first thing we want to find is our total capacitance in a series circuit. We see here formula number 4. In a series circuit, to find capacitance, we have to use the reciprocal formula. So we're going to go 1 over under 1 over under 0.1. Alright, this value 0.05 times 10 to the negative 6, scroll over, plus 1 over under 0.02 times 10 to the negative 6, and my total capacitance here. Now it gives you the answer in nano, but I want all of your answers in micro. So to convert this nano answer to micro, simply hit shift and hit engineering again, and it will convert it to micro for you. So it's going to be 0.013 microfarads. I know we've been going 2 numbers after the decimal, but I'm going to make an exception in our farad values, and we're going to go 3 numbers after the decimal in this case. All right, so now we've found our total capacitance. We can begin to calculate our capacitive reactance. Remember that inside of these parentheses here, we can use Ohm's law. So the first step that we're going to take, now that we have our total capacitance, we're going to apply formula number 9 to find our total capacitive reactance. So it's going to be 1 over under 2, hit shift, exponent button, pi, times, we need our frequency. We see our frequency right here. When we punch it in, make sure that you make it kilo. So 1.591 times 10 to the third times our total capacitance of 0.013 times 10 to the negative 6. We hit engineering and it shows us that it's 7.69. All right, to find our XC1, all we have to do is scroll up and change our CT value to our C1 value. Hit engineering, and that shows us that that's 1K ohms. To find our XC2 value, we're going to change our value here of our capacitor that we got from the formula, so we know this is our capacitor value. We're going to change it to 0.05. Gives us a value of 2K ohms. To find XC3, go up, change this value to C3, 0.02, 5K ohms. And understand that 1 plus 2 plus 5 is 8, but there's a little bit of a rounding situation because we did not use all of the decimal places on each one of our capacitors, so that's close enough. Alright, now our next step, we're going to find all of our I values. So we take 120 volts divided by 7.69 K ohms of capacitive reactance, and that gives us 15.06 milliamps. Current stays the same in series, so we can fill in all of our I values. Now we have 2 out of 3. We can find our VC1, the voltage dropped at the first capacitor, by taking our 15.06 milliamps times 1K ohm. Gives us an answer of 1506 volts for V1. Take our 15.06 milliamps times 2K ohms, and this gives us 30.12 volts for our VC2. 15.06 milliamps times 5K ohms. This gives us 75.03 volts for our VC3.